Today, we're going to pull back the curtain on the invisible world of molecules. We're diving into the secret rules, the hidden handshake that governs literally every single chemical reaction. I mean, have you ever really thought about that? You mix two things together and you expect, poof, instant reaction. But most of the time, nothing happens right away. So what's the deal? What are they waiting for? Well, it turns out there's a very specific checklist they have to get through first. And the first rule, the absolute rock bottom #1 rule of chemical reactions, is actually super simple. Before anything else can happen, the molecules have to physically meet. They have to collide. And this whole idea has a name. It's called collision theory. It's the starting point for everything. It says that for reactants to actually, react and make something new, their molecules can't just be floating near each other. No, they have to literally run into each other. Now, to make sense of this, the theory simplifies things a lot. It asks us to just imagine that molecules are tiny, hard spheres, kind of like microscopic billiard balls. And a reaction only happens when these little balls smack into each other. We can even measure how often they're crashing around, and we call that the collision frequency. But hold on a second. If these molecules are zipping around, crashing into each other trillions of times a second, shouldn't reactions be going off constantly, everywhere? It brings up a pretty big question. Why isn't the world just one big, chaotic chemical reaction? And that is where things get really interesting. Because that leads us to the second crucial condition. It's not just about colliding, it's about how they collide. We need to talk about the energy hurdle. That's right. The vast, vast majority of these collisions are, well, they're duds. They're just gentle bumps, little nudges. The molecules just bounce off each other completely unchanged. To get a real reaction, you need something more. And that something more has a name: threshold energy. Think about it like this. If you want to break a board with your hand, a gentle tap isn't going to do anything, right? You have to hit it with enough force, enough energy to actually make it snap. It's the exact same idea for molecules. They need to smash together with enough force to break their old bonds so they can form new ones. Okay, so let's do a quick recap. Rule 1, molecules have to collide. Rule 2, they have to collide with enough energy. That pretty much covers it. Simple, right? Yeah, you probably guessed it. It's never that simple in chemistry. There's one final, really specific piece to this puzzle. It turns out that even with all the energy in the world, a collision can still fail if the molecules aren't lined up just right. This brings us to the final rule. You've got to hit at the perfect angle. And check this out. This diagram from our source material shows it perfectly. On the left, you've got an improper orientation. See? The molecules collide, but the active parts, the parts that actually need to connect, they just miss each other. So, nothing. They just bounce away. But now, look at the right. With the proper orientation, bam! They hit at the exact right spot, allowing those new bonds to form. That's how you get a product. So, when you finally get that perfect storm, a collision that has both enough energy and the perfect orientation, you finally have a winner. And this very special, successful type of collision has a name. It's called an effective collision. And that's really the whole game. It's the combination of the right meeting with the right energy at the right angle. Only effective collisions are the ones that actually result in a chemical reaction. So, to boil it all down, the 3 keys that unlock any chemical reaction are these. 1, the molecules have to touch. That's the collision. 2, they have to hit with enough oomph. That's the energy. And 3, they have to line up just so. That's the orientation. You miss even one of these, and the reaction is a no-go. Now, it's really important to remember that as powerful as this theory is, it's still a model. It's a useful simplification, not a perfect mirror of what's happening. It definitely has its limits. And our source material points out a major one. It says that the theory treats molecules as simple, hard spheres and totally ignores their complex structural features. And that's a key point to remember. Real molecules aren't just little marbles. They have these intricate 3-dimensional shapes with different parts that have different charges. Collision theory is an awesome way to get the basic idea down, but it does gloss over all that amazing complexity. So after exploring all of these rules and the fine print, what's the single most important thing to take away from all this?
It's this. For the magic of chemistry to happen, it's not nearly enough for molecules to just be in the same place. They have to collide. They need to do it with enough energy, and they absolutely must hit at the perfect angle. It's an incredible combination of physics and pure chance, happening on a scale we can't even imagine.
And that just leaves you with a fascinating thought, doesn't it? If these are the invisible rules that govern chemistry, what other hidden rules are shaping the world all around us right this very second?